Hello friends, this is part 4 of Electromagnetic Theory, paper C-13 of 2024, 6th semester Dibrugarh University. Before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT 123. This is my Insta ID. You can follow me on Insta. So we have already solved up to question number 3, right? Today we're gonna solve the questions. We're gonna answer the questions of question number 4. So let's start. So here question number 4 is, so that electromagnetic waves in free space are transverse in nature. So let me show this one. So here you see, first let me write the Maxwell's equations for free space. For free space, this equation number 1, 2 and 1, 2, 3 and 4, these are the Maxwell equations. Okay, so I have not written the meaning of the symbols E, H, okay, but do mention this. So actually I have already mentioned in earlier videos many times, so that's why I have not written here. But in exam, don't forget to write the meaning of the symbols that you have written or that you have used in your answer. Okay, and then equations for electromagnetic wave in free space are given by these two equations, equation number 5 and equation number 6, and their solution will be of this form, equation number 7 and equation number 8. Okay, so take the screenshot. Right now, let me go to new slide. So here I have written this k vector which is propagating vector constant, propagating vector, okay, which is equal to k. This is n cap, unit vector along the propagation in the direction of propagation of wave, which is also equal to this and also equal to this, also equal to this. So hope you know these things. Value of k is equal to 2 pi by lambda. Also you know, this lambda will be given by nu by c. Nu is the frequency, and in terms of angular frequency it can be written this way, right? And the vector r that we have used here you can see in this solution of this wave we have used, this is nothing but x I cap, y j cap, z k cap, and this E naught also can be written, it must also have 3 components: E naught x, E naught y, E naught z, right? And similarly this k vector also has 3 components: kx, ky, kz. So that's why in the vector form I can write this kx I cap, ky j cap and kz k cap. Hope you have understood this. So here this divergence of E, so divergence, this del vector is this one, del del x I cap, del del y j cap, del del z k cap dot, and this E is equal to that, let me go to previous slide. Here I have already written that this E is equal to E naught e to the power I k dot r minus omega t, right? So that is what I have written here instead of E. Okay, now you see k dot r, if you take the dot product of these two, if you take the dot product of these two vectors, k dot r, that kx I xi I cap 1, so that's why kx into x. Similarly we will get ky into y, kz into z, right? So hope you have understood this. Now you see what we are going to do. We are going to, so here you see dot product, we have here dot product. So here if you find the dot product, then what you're gonna get, del del x, here I cap 1, then e to the power E naught x is constant, so E naught x, then you need to differentiate this e to the power I, this one, and if you differentiate this with respect to x, if you derivative of this one, now you see if you have e to the power x, ddx of e to the power x is e to the power x, right? And if you have suppose e to the power mx, then you have to write m e to the power mx, right? So here you see, if you apply this one here, if you differentiate this e to the power this one with respect to x, then if you take the partial derivative with respect to x, then you have to take this remaining terms as constant. So derivative of this e to the power ikx, that's why here this term will be here, you see ikx. Similarly, if you differentiate with respect to y, then this remaining terms will be taken as constant. Then e to the power here e naught y will be here, this is y component, will be taken as constant. Then e to the power, then this terms will be taken as constant. We're gonna take the y component only. Then here ky, so and I will come out, so I have taken here I as a common, right? Hope you have understood this, what I am doing here, right? Because you see, when you take the dot product of this one, these two, then I cap j cap, that's gonna be 0. Dot product of this I cap k cap, that's gonna be 0, right? That's why we're gonna get del x of this one into this, then del y of this del y of this one into this, then again del z of this z component into e to the power this, right? Hope you have understood this. So when you differentiate this with respect to z, then I kz will come out, I kz e to the power, again we're gonna get this, whatever it is, whatever the power is here, that's what we're gonna have. Okay, so hope you have understood this, right? Now you see, let me clean it. So we're gonna get this term in each and every term, okay? So that's why it is taken as common. And when you differentiate this with respect to x, ikx comes out. Similarly, when you differentiate it with respect to y, iky comes out, right? Then with respect to z, when you differentiate it, ikz comes out, and I is taken here common, right? So hope you have understood this. And so now you see, this part can be written as k dot e naught. This is dot product of k vector and e naught vector, right? This is k vector, here you can see this is k vector, and this is e naught, right? If you take the dot product of these two vectors, then you're gonna get this result, you're gonna get this part, okay, right? So that's why I have written, instead of this, I have written k dot e naught, okay? Let me write it properly, k dot e naught, okay? So now you see, e naught into this is nothing but e vector, so that's why I have replaced it by e vector. So we have got divergence of e is equal to I k vector dot e. Similarly, we can show divergence of h is equal to I k dot h. So that means we can say del operator can be replaced by I k vector, right? Now you see, if we use the equation number 1 and 2, here you see this these two, if we use these two equations 1 and 2, so divergence of e and divergence of h for free space equal to 0. That's why if we put here 0 using 1 and 2 in 9, we gonna get this result. Using 1 and 2 in equation number 9, we have got k dot e is equal to 0 and k dot h is equal to 0. That means I k dot e is equal to 0 and I h dot is equal to 0. That means if I k dot e 0, then k dot e also 0, right? That's obvious. So dot product of these two vectors is 0. That means what? E and k perpendicular, and dot product of k and h is 0, means h and k also perpendicular. That means these two both are perpendicular to this k, which is the direction of propagation of the wave. So if E and then H, it is obvious that this wave must be transverse wave. That's why electromagnetic waves are transverse in nature. That's how we can show. So now let's move on to next question. what is the next question here? Find an expression for conductivity of ionized gas region on the basis of propagation of electromagnetic waves through ionized gas. So let me go to the answer to this question. Let me write here. So this is the equation of the EM wave through ionized gas, and its solution can be written as this. Already I have given in the previous answer. So now we know that force on electron, so F is equal to, we can write E into capital E vector, and this E is nothing but this one, which is this, right? So here we have replaced this E by this result. So now you see that force is equal to mass into acceleration, and acceleration is given by second order derivative of position vector with respect to time. Hope you know these things, right? First order derivative of the position vectors gives velocity, right? Velocity, and its second order derivative, if you take the second order derivative, then it's gonna give you acceleration, right? This is nothing but this one, right? Hope you have understood this. So let us divide both sides by m, right? Then this two m's cancel, so we're gonna get this step, right? So hope you have understood this. Now integrating both sides, if we integrate this, so this second order derivative becomes first order derivative after integration. That's what we have got, right? And if we integrate this term, right, we know that integration of e to the power mx dx is equal to e to the power mx by m. If we apply that, then so we are integrating with respect to t. That's why this I minus t minus omega will be there. That will be comes in the as denominator. That will be coming as denominator. Okay, so now so this is replaced by velocity. Okay, so here you see, if we multiply both numerator and denominator by I, so then I gives minus 1. This minus 1 into minus, that's gonna give you plus. So that's what we're gonna have, right? So hope you have understood this. Now we know that current density, the current density is given by J is equal to NEV. Current density is this, and this V is replaced by this result here. Okay, this V is replaced by this result to obtain this. Now you see this current density relation between the current density and conductivity is given by this relation. I have replaced this J by this. Then from here this 2 cancels, so we have got the conductivity expression for conductivity. So hope you have understood this. Now let's move on to next question. Question number 5. Explain the phenomenon of total internal reflection with the help of electromagnetic theory. So I have already made this video, made a video on this topic. I have written the definition of this evanescent waves. So take the screenshot of this. So this is the definition. Okay. Now I have also made a video on this topic as well, Fresnel's equations for non-conducting medium when electric field vector is normal to the plane of incidence. This is one case. There are 2 cases. One is normal to the plane of incidence, another is parallel to the plane of incidence. I have written both the cases in the same video. Okay, so link is in the description box. I have written question number 5 and question number 5, or then links are with that in the description box. So go watch those videos for this for the answers to these questions. So now thank you for watching. See you in the next video. Bye bye.